Hello everybody, welcome back. Finally here we are. Yesterday I tried to go live but I couldn't because of the network issue. And because of that, still facing the network issue. Crazy. Hopefully I'm not gonna be facing anyway. Alrighty, as for this network thing, I don't know whether I'm gonna be facing it or not. By the way, we will be talking about HLD related stuff today. So let's see how it's gonna be going on. And here we are. Of course I'm live. Thankfully I'm live. Yesterday, okay, this was unlisted. Let me delete this. And let's get started without any further delay. Though I know there's been it's been many days, even going live, so that's understandable. I get it. It's been my bad from my side, but okay, never mind. I hope I'm audible. Okay, so without any further delay, let's simply get going. We are mainly gonna be talking about the things that are mainly theoretical things that are mainly related to the HLD. You must be knowing the full form. HLD is the high level design, and mainly in high level design we need to take care of two things like application layer and transport layer. But as we got this got the chance, so let's learn about all these layers. So this is the simple summary stuff. Like in application layer, applications create the data, so ultimately data is created over issue. Yeah, sort of can't really do anything. I'll have to just simply keep going. This is the only thing that I can do. Okay, and then there is something called session layer. This just simply establishes the connections and manages. Again, when it comes to the connections, so that can be duplex, that can be full duplex. I mean, this is how the things go on. In the transport layer, data is actually broken into segments for the reliable delivery. Again, these are just the extra stuff that I have written here. Then there is something called network layer. Segments are packaged into packets and routed. So ultimately, whenever you are sending, in the transport layer, the same data is converted into segments. In network layer, that is converted into segments are packaged into packets. So ultimately, the data gets converted into packets. In the data link layer, packets are framed, so ultimately it becomes the frames. So transport layer has segments, network has packets, data link layer has frames and sent back to the next device, and physical layer is responsible for frames are converted into bits and transmitted physically. So this is the overall thing that happens. So application layer just simply gives us the data. Presentation layer sort of formats the data in the whichever format is needed and encrypts the data. When it comes to the session layer, it makes sure that connection, it manages the connection. So suppose you are sending some data to the other person, so it makes sure that the connection is established though. And then transport layer, it just simply converts it into the segments, right? And then the network layer, segments are converted into packets and then they are transmitted in all. In the data link layer, packets are again converted into packets are actually framed, so they are converted into frames and they are sent to the next device. In the physical layer, at the end of the day, frames are converted into bits because the data transfer into 1 and 0 and all. So it's converted into bits and all, and it is just simply physically transmitted. Again, where I got this thing from, I got it from here. Okay, and talking about this thing, we can just simply have an example over here. We can understand how the flows through. Can I turn on the light mode? Dark mode. Dark mode. Yeah, I can. Here we are. That's better. So I was just simply going through this tutorial, and because of that thing I just came to know about all these things better. And step on, a person interacts with email application like Gmail, Outlook, etc. Writes his email to send. This happens application level. That's great. At presentation layer, mail application prepares for data transmission like encrypting the data and formatting for transmission. At session layer, there is a connection established between the sender and the receiver on the internet. So yeah, this is the session layer mainly manages the session between two users, senders and receivers. And at the transport layer, email is broken into smaller segments. It adds a sequence number and error checking information to maintain the reliability information. So as the data has been chunked into segments, so we need to know the kind of sequence of the segments, and that is why event sequence number is added over there. At the network layer, addressing packets is done. So in order to find the best route of transfer, ultimately segments are converted into packets, and then at the data link layer, data packets are encapsulated into frames. So ultimately, what happens? We have segments over here, then they are converted into packets. Then packets are again in turn converted into frames. Then MAC address is added. So ultimately, in the data link layer only, you add MAC addresses and all for local device, and then it checks for either using error detection. The thing is that when you are sending the data, if you are sending the data from one device to the other, and if that is in the same network, so how will you be able to find that? So I think that's where MAC address and all that is used. And lastly, we have physical layer. Frames are transmitted into in the form of electrical optical signals over the alrighty. So this is what happens. So ultimately we have first of all physical layer. Physical layer establish physical connection between devices. So data is sent into bits and all protocol data unit, and USB, SONET, SDH. These are the protocols that are used. Let's not worry about them. You just need to have the idea exactly what happens. And then data link layer, node to node delivery of message. So there can be different nodes, and that's sort of right. You get the data. Once you got the data, then there can be different nodes sort of. And the protocols are Ethernet and PHP. Nodes in the sense what? There can be different routers. Could be anything. Okay, and node to node delivery frames are the ones that are sent here. Transmission of data from one host to another located in different networks. Network layer just simply again converts frames to the packets, and it just simply goes on. Then in the transport layer, takes service from network layer and provide it to the application layer. Segments for TCP or datagrams for UDP. So TCP uses segments, UDP uses the datagrams and all, and these are the protocols that are used here. Again, my goal is not to have to be the best in it. Just having the information is enough. Establishes the connection and maintains, ensures authentication and ensures security. Okay, that's fine. Data from application layer is extracted and manipulated in the required format for the transmission and all. And lastly, you have application layer. You just simply show the things and all. Okay, so this is how the things simply go on. This is the overall summary of it, and let's simply continue from here on. By the way, in HLD we are mainly gonna be talking about these two things. We are gonna be talking about application layer, and we are gonna be talking about transport layer. Application layer is responsible for just simply creating the data, giving us the data. Transport layer is mainly responsible for converting the data into segments, so that in further they can be converted into packets, and then in the frames, and they can be okay. This is the flow. You get the data from the application layer. Okay, then you have the presentation layer. Data is actually formatted and encrypted, of course. Then you have the session layer that make sure that the connection is established between two clients. And then you have transport layer. In this particular transport layer, if you are using TCP, then you are gonna be the data will be converted into segments. If you are using UDP, it is gonna be converted into datagrams, as we just we've seen. And after transport layer, you have the decision all, and lastly you have the physical layer. Yeah, the frames and everything else converted into bits, and then the data is transmitted. That we use there can be many more. And in the transport layer, we use the TCP and UDP, by the way, transmission control protocol. Use the datagram protocol, the full form of these. HTTP hypertext transfer protocol. S stands for security. So what is the secure shell? I mean, there is a full form. By the way, it mainly stands for security over here. Then we have FTP file transfer protocol. We have SFTP secure file transfer protocol, if I'm not wrong. We have SMTP simple mail transfer protocol. WebRTC you must be knowing. WebSocket must be knowing. Okay, so this is how it just simply goes on. So let's simply continue. By the way, if I go here, just a second, give me a moment. And it is more or less gonna be theoretical part, because I've been learning it for 5 days or around, but I haven't seen any, like, even if I have been going through a course, they've been just simply talking about the theoretical stuff. So yeah, right now, even whatever I'm gonna be discussing, that's gonna be just the theory. Later we will be implementing all these things. So we've talked about application, transport, FTP, SMTP, and all these things. Let's continue from here. By the way, when it comes to system design, so there are two parts. A low level design, low level LLD, and HLD, high level design. Low level design merely requires the knowledge of DSA, of course, and for that thing I need to be good at DSA. I'm just simply working on that. Hopefully very soon I will be able to. Once my DSA is done, I will be exploring the LLD part, or probably when I'm in the middle of my DSA, then I can start exploring that. But as for right now, let's simply keep it on pending. Let's simply get this HLD done first of all. Okay, so this is the thing, and let's talk about some of the things that I may be missing. Okay, so system design has two parts, and when it comes to the just a minute, mainly in HLD what we discuss about the tech stack, exactly what we are gonna be using, whether we are gonna be using MERN, Spring Boot, Django, etc. And we talk about the databases, we talk about like which database we are gonna be using. So ultimately HLD is all about high level design. That simply means on a high level what all you are gonna be taking care of. So you will be taking care of the tech stack, just a sec, you will be taking care of the database, you will be taking care of how much traffic you are getting on your of course on your app, and whether you are actually able to handle that or not, what should be the capacity of your database, how many databases should be there, whether they should be they should be, I mean, implementing sharding and all. Ultimately there should be many databases or not. I mean, there can be many things, right? So ultimately on high level design you just simply take care of all these things, and we are just simply gonna be going through them one by one. So overall what happens, that you just simply send a request from, I mean, you must be knowing about request response models. So you just simply send the request from the browser, or that can be mobile app as well, to the server just simply sends you the response back. And when the request actually goes to the server, so if you have many users sitting only one server, so that server may crash, and all these things are actually handled on HLD. So as the server may crash, so you just simply use distributed system. So it's pretty simple, like you have a normal client side, you have a normal server side, you just simply send the request from here to here, you get the response from here to here. But the problem is that even though this is the client, come on, can't I make it bigger? Of course I can. And this is the server, just like this. If there is only one server, as we keep sending the request over there, after some time this server say, okay, I do not have enough storage, enough RAM to just simply continue serving, and then it will just simply crash and all. And that is why we need something called distributed system. Distributed system in the sense you will have many servers, and the request is gonna be load balanced among them, and this way one server will not have to go through a lot of load. So this is the thing that we are gonna be discussing about. Having said that, there is something called load balancer. So load balancer will be balancing the load. Not only that, load balancer behind the scene uses a lot of algorithms. We are going to be talking about those algorithms. When we distribute them, there are lots of algorithms. When we distribute servers, when we distribute a database, of course they can be actually distributed as well. So whenever we just simply create many replicas of something, at that time ultimately that is distributed and all. So there are algorithms for that. So we are going to be talking about all those algorithms, and this is again going to be theory part, of course, but yeah, we will be going through them. Of course we are going to be taking the help of AI as well here, and we'll be digging deeper into them. So let's continue from here on. By the way, this is just the starting point. And when it comes to even there are two things, horizontally scaling and vertically scaling. Vertically scaling means what? Vertically scaling means this is a server that you have. This server has some storage. This server has some RAM and all, ultimately CPU capacity and all. RAM, you can call it CPU. So what happens that as you get a lot of storage, as you get a lot of traffic, you just simply increase the storage, RAM or CPU. So you just simply increase the power of this machine, only one machine. That is called vertically scaling. So you are vertically scaling it, you are adding more and more power to this, you are giving it more storage, more RAM and more CPU and all. But how long can you even do that? If your if your RAM or CPU, suppose, I hope the RAM, if the RAM is suppose 16, then you made it 32, then you made it 64, you can keep making it, keep increasing it, but that's gonna be a limit where you will have to stop anyway. And that is why again this is called vertical scaling. And the horizontal scaling is that you create not this actually, horizontal scaling is that's bad. you create multiple instances of this. So ultimately you will not have just one database, one server, rather you will have many. And when the client sends the request, so there will be a load balancer in between that will be just simply managing whether the request should go to this one or to this one or to this one, and this is how the things are gonna be going on. So this is called horizontal scaling. Again, there are algorithms for it, exactly how you should be horizontally scaling and all. So we are gonna be talking about them. Again, there's no time limit. We have started it, and again, whether the network remains, persists or not, it doesn't really matter. It needs to be ended here. Like there are 5 lessons actually that I have to go through. So let's simply go through them one by one. So we have talked about horizontally scaling and vertically scaling, and apart from this particular thing, nodes we have already talked about. By the way, if you know about Kubernetes, so what happens over here in Kubernetes section mainly, that you have different nodes. So you have main cluster, Kubernetes cluster here I'm talking about. So you have main Kubernetes cluster. Inside the cluster you have many nodes. Those nodes can be denoted as anything. So suppose, well, that's bad. Okay, so there is this first node, and then now that's bad. Let's use rectangle only over here. First node, second node, there can be third node, there can be fourth node, there can be fifth node, and they should be able to talk as well. So this is called nodes internal responses. Like in your main cluster there can be many nodes. Those nodes are going to be running many pods, of course, and they should be able to talk to each other. I'm not going to be talking about this much because over here cluster IP is used. So ultimately your cluster itself has its own network, internal network, and if one node needs to talk to each other, they can just simply talk to each other, and you can use something called cluster IP. Again, we have talked about it, we will be talking about it later as well. So this is how the things just simply go on. And network communication, we have already talked about this ISO. This is what happens when you just simply talk, you send the request to the other client. So application layer, presentation layer, session, transport, network, data link, and physical layer. If you have the basic idea about it, that's enough. You don't really need to worry about it. So network communication are rules that both clients and server follow to communicate. So suppose here I'm using a TCP, so another one should be using the TCP only, right? So the client is sending the data using TCP, so this receiver should be using TCP. If we are using UDP over here, so UDP should be used over here. So mainly we are going to be talking about two things: application layer and presentation layer, and these are the protocols that are actually used over here. Okay. As for the application layer, we have already talked about that. This simply manages the main application part, whatever you see on your screen. And then these are some of the protocols that are used on the application layer. WebRTC, that is mainly for making the video calls and all. So if you want to have a peer-to-peer connection, at that time you are going to be using WebRTC, and WebSocket is mainly for chatting and also if you want to just simply send some messages and all. At that time WebSocket is going to be used. SMTP is for sending the message mail. FTP and secure FTP, that is mainly for sending the files and all, and HTTP and all these things, they are just simply for normal requests. So whenever you are making a request to the other client, ultimately when you are getting some data from the client, making a request to the server and all, at that time HTTP and all, HTTPS, they are gonna be used. So this is how the things simply go on. By the way, there is one important thing, the difference between TCP and UDP, because whenever you are transporting the data, that may be using TCP, that may be using UDP. In that particular case, especially if there is a client, so suppose let me make a client over here. This is the client, this is the server. So this is gonna be the client, this is gonna be the server. So not like this, CLIENT, just like this, server. Okay, this is the client, this is the server, and whenever you make a request to the server, ultimately this is how it just simply goes, right? Ultimately you make a request to the server. So when you make a request to the server, so the request goes to the server. So once the request actually reaches to the server, so ultimately what you say, you just simply request to make a connection with the server, right? So there is something called synchronization. I'm not sure. TCP diagram, let me see. TCP model. You just simply send a request. TCP IP model. Can I see something interesting here? Needle. Not this model. TCP diagram. connection diagram establishment. I mean, this is what I wanted to. TCP connection establishment. Ultimately what happens, I'm not sure whether I'm gonna find that or not here, but ultimately when you send a request to the server, you just simply send a synchronous message, call it hello, you just simply say hello, I want to make a connection. So suppose this is a synchronous message, and after that server responds you back. So server acknowledges your request. So server is gonna server is also gonna send the synchronous message, plus server is gonna acknowledge your message, and once server has acknowledged your message, you will have to acknowledge back, and this is how your your TCP connection gets connected. So ultimately what happens, this is three-way handshake. So at that time you just simply send suppose you say, hi server, I want to make a connection with you. Server first of all acknowledges that okay, this person wants to make a connection with you, and this person then sends hi to you as well, okay, you want to make a request, and then you say you acknowledge as well that okay, now the connection is made. I mean, this is how the things simply go on, and I should be getting some kind of, okay, here it is. So this is what I want to talk about. So there is sender, there is the receiver, and maybe not and all, you can just simply go through them, know more about them, but for now this much is enough. Okay, so this is the thing. And by the way, when the connection in UDP, the things are very simple. UDP, if you are using UDP, the data will start getting sent to the server or to the client, call it anything. So if you are using TCP, TCP, there's gonna be three-way handshake. If you are using UDP, the data will start getting sent using UDP. I mean, if you are using UDP, user data protocol, a datagram protocol, so the data will be sent directly to the server. Now server receives it or not, that doesn't really matter, even if it is a client. So this can be sender, this can be receiver. So the data will start getting sent to the receiver directly. Whether the receiver is ready or not, that doesn't really matter. So this is what is handled by UDP. So this is how we are gonna be going through the things, and let's talk about the overall flow, exactly what happens. So we have a client over, so this is gonna be the server, just like this. So we have this is the client, this is the server. So whenever we are making a request to the server, the thing is that the request doesn't directly go to the server, rather, because you will be entering your DNS name, right? And then we have something called domain name service, DNS, if I'm not wrong. What is the full form of DNS over here? DNS full form, so domain name system actually. Okay, so there is something called domain name system. Let me have the full form over here as well. Domain name system. So whenever you send the request, so the request first of all goes to the domain name system. So the request is actually gonna go here. First of all, I can use something called just a minute. Alrighty, this is better. So the request actually goes to the domain name system. From the domain name system, you are gonna be getting your IP address and all. And once you get your IP address from the domain name system, then the client is actually gonna send the request to the, using that particular IP address, the request actually sent it to the server, and from the server then it just simply processes the things and you get your response back. And having said that, there can be many things in the middle. There can be middleware as well. There can be something called API gateway that just simply validates the things and all. We will be talking about it. I just know about it theoretically. I haven't really implemented it yet. So let's see how it's gonna be going on. But overall, this is what happens. Now there can be many things. There can be a load balancer in between. There can be many servers. So not only one server. There can be actually many servers here. Not only servers, there can be database as well. So suppose this is the database that we have now. Really bad thing. So this is the DB that we have. They will be just, they might be using the same DB. It could also be the one. So they might be sending the request to the one DB, or there could be cases like there can be multiple DBs and all. So all these things are actually handled in the HLD section, and we are going to be talking about these things. LLD may be focusing on the code part, ultimately how the things are implemented, and HLD focuses on what things are implemented. That's a good one actually. Okay, so without any further delay, let's move to the next. This was just the intro part, and now we are going to be talking about what? Now we are going to be mainly talking about the architecture, exactly how the things are architected. That's sort of right. So we have talked about the basic stuff right now. Now how you are actually going to be adding the database, how you are going to be scaling the database, how you are going to be scaling the servers, And then of course in the later sections we are going to be talking about the what is that thing called algorithms, how load balancer, what kind of algorithms are used in load balancer, what kinds of algorithms are used when you are scaling the servers, databases and all. So we are going to be talking about all these things. So without any further delay, let's simply get going. So this much we have discussed. Ultimately when it comes to the what, let's talk about the overall client and server side. So suppose this is the client that we have, simple. So we have a normal client over here, then we have a normal server over here. I'd better just simply use what, xcalidra for that, xcalidra.com. I mean that does the better job in this case. Let me use system. Okay, this is fine. So what I was just simply saying that it does work like great. So I have this client over here. Okay, I have a client client over here. Hopefully it's gonna be fine. Yeah, that's right. So I have the client over here, then of course I'm gonna be having the server as well. Right, what am I doing? This is insane. Then I'm gonna be having a server as well. Let me talk about this well. Let's create proper diagram so that I can mention the things properly. So we have our client, and that can be mostly that is called client tier if I'm not wrong. So we have web browser sending a request to the server. So let's simply do that. This is mainly gonna be the client. Client can be anything. Client can be your web server and all. Okay, so let's not worry about that. And then this is gonna be the server here. You just simply do what? You just simply send the request from client to the server. So from here the request is gonna be sent to the server. Now the request doesn't really go directly, so ultimately you will have to use DNS over here. So that's gonna be DNS, domain name service, of course. That DNS will be just simply giving you the IP address and all. So it can be somewhere here. The request will go to the DNS, and from the DNS you get the response back. When you get the response back, ultimately you get the IP address, nothing else. So you get your IP back. Once you get your IP back, you will be sending the request to the server. So the request goes to the server, you get your response either in HTTP format or in the JSON format. It's completely up to you. Oh, sorry, not HTTP, HTML. I mean in any format, you just simply get your data. J gonna be some type of certificate validator, and that will validate the certificate, and that at the end the request will be sent on port using HTTP protocol. So this is how it just simply happens, and that is it. Then let's so this is the simple client server architecture. Now what is the next thing? If we want to introduce a DB, so we have the server over here, that's great. Now we can just simply introduce a DB as well. So when it comes to introducing a DB, so let's do that. So when it comes to DB, so suppose this is where I have my database. This is gonna be DB. So my server will be talking to the database. I mean, this is pretty simple thing, right? So you can introduce even DB as well. So your client will be sending the request. So first of all, the request will go here. So this is gonna be the first one, not first one. This is gonna be the first one. Come on, can't I? Hey, 1, 2. Literally, bro, I'm not able to. Now this is fine. 1, 2. So the request goes to the DNS, then you get the response back. When you get the response back, the third number, the request actually goes to the server, and then you get the response. By the way, once the request goes to the server, server may contact, talk to the DB. Then DB will send you the response, and then you will get the response back. So ultimately, you will be getting. Well, this is something that I have to remove from here. Let me even remove this HTTP. That doesn't really matter. And as the 7th number, you will be getting your 7th or 1, 2, 3, 4, 5. This is gonna be the 6th. So at the 6th step, you are gonna be getting your data back. So this is how ultimately you will be getting the response from the database. So this is how it happens, and this is how the overall flow goes when you just simply introduce the DB. Let's talk about the multiple servers. So you have your client, okay, you have your DNS, now you will have multiple servers over here. So if I just simply remove this particular part from here, so what I want to do here, that instead of having just one server, you are gonna be having multiple servers. So this much is gonna be the same. But when it comes to the server, so there's gonna be, suppose this particular section here, it will actually contain multiple servers. Those multiple servers can be inside a cluster and also no need to worry about that. So suppose this is the cluster, and ultimately even the client is gonna be inside the client front end is also gonna be hosted inside the cluster. So suppose these are the servers I have, so that can be server number 1, this can be server number 2, this can be server number 3. Now whenever you send a request from your client to the server, so it's not like the request will directly come here, because there are 3 servers, and which one the request should be going to, and that is why there's gonna be something called load balancer in between. So there's gonna be load balancer in between, LB, not LG, of course LB. Come on, yeah, that's better. LB load, come on, yeah, LB load balancer. So what this load balancer does, that this simply balances the load on the servers. So you are gonna be getting the request over here on the load balancer, and from a load balancer will decide whether the request goes should go here or to this one or to this one. So this way request is actually just simply balanced among the number of servers that you have. So this is how it just simply goes on. Alright, so we have talked about this thing, and once the load balancer, again one important thing, when one client sends the request to the DNS, okay, the DNS gives you back your public IP address. So public IP, you just simply get your public IP from your DNS. Once you get the public IP, you just simply add the third number, you send a request to the of course load balancer, again using your public IP. So the request goes here using your public IP. Once the load balancer gets your request, of course with that particular IP, the load balancer knows what is the private IP of these servers, because they should not be directly exposed, right? So if you have a backend, your backend should not be directly exposed using private public IP, and that is why these nodes ultimately, even if they are just servers, they are at the end of the day nodes, right? Inside the nodes, pods are running. Inside the pod, your different applications are running. It could be server, it could be front end, it could be database, and all depends on exactly what you are running. It could be different microservices and all. So there are two things, right? What there is something called monolith, I think this is the one, monolith architecture, and then there is something called microservices. So it could be that your payment is being handled by one, your requests are being handled by one, your database is being handled by one service. So ultimately you can create multiple services and all. So ultimately when you get the request to the load balancer is gonna be using your private IP addresses and all, and using the private IP it will just simply send the request. Again, it already know it may send to this one, it may send to this one, it may send to this one, and there are different algorithms based on what there is something called Robin round algorithm. Like it will send the request to the first one, then the second one, then the third one, or you can even check the load on this one, on this one, on this one. On the basis of the load you can send, or you can check the number of requests, how many requests this is handling, this is handling, and this is handling. You can check the weight, like what is the capacity of this one, and this one. So there are many algorithms. Using them you can just simply send the balance the request that you get. But all these things are gonna be talked about later. And lastly we have this of course we will have the database as well. This is gonna be the fourth number anyway. So this can be fourth number, this can be fourth number, this can be fourth number. How will the load balancer be deciding which one to send the request to? We will be talking about those algorithms as well. So for now consider it like this much only. And then there's gonna be of course database as well. So suppose this is the database that we have, this is our DB ultimately when it comes to this particular DB database. So there's gonna be 1 DB, so this is gonna be the fifth request. And of course from the database you are gonna be getting your from the database you are gonna be getting your response back, sort of like this. This is gonna be the sixth step. And from here you your server will get the result from the database, and it will just simply redirect it back. So the data will be redirected from any one of the servers. So this is gonna be the seventh, and then it will just simply forward it back. So 7 I said, and then from here it will be redirected back to the client. So this is what actually happens here. I hope I'm right. Okay, so this much is done. So this is how the overall flow goes on. So over here, what you have done, you have distributed your servers. Now you have many servers. Load balancer will decide which one to send the request and all. So that's not really a big problem. One thing I can definitely do here, that is changing the colors of this. So these are the servers. This is the database. So database is always gonna be like this. This is the client. The client is always gonna be green. Well, not this one. This should be white. Load balancer, this should always be this, not this. So probably this. No, that's bad. Let it be white. Okay, so this is how the things are actually gonna be going on. So the client sends the request, the load balancer will forward the request to the one of the servers. The request will go to the database. Again, this is the single point of failure. So single point of failure, single point of failure. So single point of failure. Single point of failure. Okay, single point of failure, that simply means you have many servers, that's great, but you have only one database. What if that database gets a lot of requests and it just simply runs out of the storage? Then what will you do? In that case, that database is gonna crash. Ultimately it will, if first of all this thing, that what if there are a lot of customers and they just simply keep sending the data and your database is full. There's no storage and all. The second thing can be if this database goes down. So suppose there's no database now, it just simply went down and now you have nothing. So if someone sends the request, even if you have servers, they will talk to the database is not running anymore. And because of that thing, if your database goes down, your whole application will be down, and it's better to just simply distribute the database as well. And that's what we are gonna be doing. So first of all, we talked about normal client and server architecture, the simple one, like how the things work and all. Then we introduced the database and how the database is, just simply works behind the scene. And then we talked about even distributing multiple servers, like how you are going to be distributing multiple servers. And load balancer will be just simply balancing the node and all, but load and all. Then the next thing that we are going to be doing, that is because here database is actually being becoming the single point of failure. That simply means if something goes to the goes wrong with the database, that simply means you are gone. By the way, let me just give them proper names. This is mostly called client tier. Client tier. Now why is this called, I don't know. So as I have the name, so let me keep it here. This is gonna be the client tier, sort of client section. This is gonna be the server tier. Server tier. Again, probably I may have good idea about all these things later on. This is gonna be the DB tier. So this is how we are just simply gonna be going ahead with the things. Alrighty, let's talk about DB scaling. Exactly how you are gonna be scaling the DB and all. So there is something called master slave. So suppose you have 2 DBs. So now instead of having 1 DB over here, let me keep it here. Let me remove it from here. So ultimately, what you will do, you will say, okay, database is the problem, right? So let me create a sort of environment inside which I will have 2 databases now instead of having 1. So suppose I have these 2 databases over here. Again, we'd better just simply talk to the AI as well regarding this thing, because it's better to know more about all these things. But ultimately, this is gonna be the database 1. This is gonna be the DB2. So ultimately, now I have 2 DBs, and this is gonna be the DB tier for sure. So whenever you are gonna be sending the request is gonna be load balanced among them. Again, this is not gonna be like the request is actually gonna be load balanced. There's gonna be a master slave. So ultimately, if I try to make it like this here, so when it comes to the databases here, DBs, ultimately database base. Okay, so there's something called master DB here. So how did I get this color? That was by mistake anyway, but I got it. In that case, let me have this. Okay, so there's gonna be master DB, and we will be like knowing more about it. And there are gonna be some slaves as well. So this is the master DB inside the web server, of course. And apart from this particular master DB, there are gonna be some slaves. Suppose this is gonna be the slave 1. Right now we have 2, so one is gonna be master DB and another one is gonna be slave as well. So slave DB, and there can be multiple slaves. So it's not like there's gonna be only one. So suppose there are 3 slaves. So ultimately what will happen when you just simply write something? So suppose you are sending the request here. So whenever you are writing something, ultimately adding something to the database and all, so that's gonna be saved in the master DB. So ultimately at that time master DB is going to be used. So whenever you are making the changes in the database, master DB will be used. And whenever you are reading something, whenever you are just simply reading something, just simply getting the data, so at that time slaves are gonna be used. Apart from this particular thing, suppose you wrote something, you added something in the master DB, that will be synchronized to this slave, and this particular slave as well, and this particular slave as well. So as soon as you just simply made some changes in the master DB, those changes are gonna be reflected in the slaves DB as well. But apart from this particular thing, whenever you want to get some data, so the different slaves, again load is gonna be balanced over here. These slaves are actually gonna be used, and then you are gonna be just simply getting the data. So ultimately this is called master slave architecture. And ultimately whenever you are just simply reading, so at that time of course your slaves are used. Whenever you are just simply writing something, at that time master DB is used, and this is how the things go on. Now the question is, if one slave dies, suppose this slave just simply dies, so at that time master DB, I mean a new, it will just simply sort of spawn a new slave. So once this slave dies, so ultimately either it will start this one, it will create a new slave. So ultimately after some time that particular slave will be back. So well, that's crazy. Let me just simply get this slave back over here. So after some time new slave will be back, and that slave will get the information, get the what data from the master DB, and it will have the same data. Now you can just simply query the data from these slaves. Apart from this particular thing, if your master DB dies, so one of the slaves, suppose this one or this one, this slave will actually become the master for a while. So as long as master hasn't come back, it will become the master DB. So this slave, one of the slaves will become the master. So even if this is slave, this will actually become the master, and once master just simply comes back, so at that time you don't really, well, that's crazy. Okay, never mind. So once the master actually comes back, suppose this is the master DB. So once the master comes back, master will get the like data from these slaves and all, and it will just simply start receiving the request. So this is how the things actually go on. Pretty simple. And that is it. By the way, let's talk about this thing this thing in detail using the AI, of course. So tell me about master slave architecture. Alrighty, so let's see how it's gonna be going on. It is gonna be taking time. And how about the network? Oh, okay, the network connectivity isn't good at all. That simply means that live is not being streamed the right way. Hopefully it's gonna be right. Coming back to this one, so master slave architecture, now often called as primary, replica, or leader follower. So the names of these changes, so this is also called primary, replica, or leader follower, is a system design pattern used in databases, distributed systems, and networking. So basic idea in this architecture, there are two types of nodes. Master, that's simply primary or the leader. The main controller handles all write operations, insert, update, delete. That's what we've been discussing. Decides what data should be changed. Slave, that can be called replica or follower, copies the data from master, handles read operations, cannot modify the data directly in most cases. How it works: client sends the request. If it's a write request, goes to the master. Master updates the data. Master replicates, copies, changes to slaves. Slaves update their data. If it's a read request, goes to the slaves. Ultimately, this is how it just simply goes on. Imagine user signs up the data. Okay, we've done this. This is what actually happens. You just simply send the request. If that is the write, goes to the master, and the data is replicated and just gets saved in the databases and all. I mean, gets saved in the slaves. If that is a read request, that simply goes to the slaves. Advantage and all. And what happens when one of them dies? Alrighty, what is the problem? Simply means I'm facing the network issue. Never mind. Okay, so let's break it down. Slave replica dies. So this is not a big problem. What happens? System continues working normally. Other slaves handle read request. Master still handles write. So slight performance drop. Fewer read nodes. No data loss. Data is safe in master. So restarts the slave. Recovery restart the slave. It syncs data again from the master. So slaves are replaceable and disposable. Master dies. This is a serious problem. What happens? No writes possible. System becomes read only or down. Slaves cannot accept writes. They depend on master. Now important part, how system handle this. Failover, automatic promotion. So one slave is promoted to become new master. System redirects writes to this new master. Manual failover. Dev debuffs promotes a slave. Automatic failover. System does it itself. Okay, that's fine. And leader election user is distributed system. Leader election user in distributed system. Slaves vote to choose a new master. Used in distributed system, so slaves vote to choose a new master. Happens automatically. Example, zookeeper, etcd and kubernetes. Okay, that's fine. And data loss risk, if master dies suddenly, some data may not yet be replicated. That is lost. And this is called replication lag. Types of replication important. Asynchronous, most common. Master writes first and sends the data to slaves, risks data loss. That's right. Synchronous, master waits until slaves confirms, no data loss, slower performance. Okay, so master is gonna wait, will make sure that slaves confirm that they are ready to just simply receive the data and all. And slaves dies, system still works, low performance. Master dies, writes stop, high. Okay, severity. Failover done, new master is selected. This is called recovery. Asynchronous, replicas, possible data loss risks, and then synchronous. Ultimately, this is how it just simply goes on. I hope you got that. So what happens if master fails? Answer: the system stops accepting writes until failover happens, where a replica is promoted to master. Depending on replication type, some data loss may occur. Okay, that's right. So ultimately, what happens here? As we already talked about this particulars. I thought I removed that, but this is here. Okay, so what happens that whenever you send the request, so master will just simply handle write request. Slaves are gonna be handling the read requests. And if the slave dies after some time, there's gonna be some loss in the performance, but ultimately that slave is gonna be back and it will just simply sync the data from the master. And this is how things are gonna be going on. Then there's something called master DB. If it dies, one slave is promoted to be a master, and after some time these slaves are gonna be voting and all, and then new master is gonna be created. And at that time, meanwhile this is happening, some data loss may happen, and this is how the things actually go on. So this was the overall flow that we have been just simply going through. So we even know about this master and slave architecture. So let me keep it somewhere here so that I have it safe. It would be better to just simply keep it here. And suppose what happens that whenever the client sends the request, the request goes via load balancer, and then server gets the gets the request, and they need to talk to the database again and again. And when they are just simply talking to the database, again they can be master as well. Suppose this is the master. Let me give it the proper name, and this is the slave, because we've been just simply talking about these things, right? So let's give them the proper name, and they are gonna be nothing but DBs. Okay, so they get the request, and now they need to talk to the what? They need to talk to alrighty. So they need to talk to the database. Now the question is that if every time your server is just simply gonna be talking to the database, the query is gonna be slower, right? So there should be a way so that if that same data is being asked, so there should be some cache somewhere, and then whenever server gets the response, first of all they will check the cache, and that's why we are gonna be introducing one more thing over here. That's gonna be something called cache tier, and we'll have cache over here. What is the use of this? We will be talking about it very soon. But it just simply caches your data. So let me have it somewhere here, or probably somewhere. Okay, never mind. Let me have it here. So whenever a server gets a request and they need to just simply get some data from the database, first of all they will check here that okay, does this cache have some data or not? And cache tier, of course. cache tier. So if this cache tier has some data, already has the data, they will get the data back from there, from here only, and that's gonna be no problem as such, and the request will not be made to the database. But if the cache does not contain the data, then of course the request will be sent to the database, and from the database the response is gonna be received. So this is how it just simply goes on. So let it be here. Later on I will be just simply keeping it at better place. So we've done this particular thing as well. So we know about caching stuff as well, like if the data is cached, get the data from the cache. If the data is not cached, make the request to the database and get the data from there. So this is what happens. And then we have something called content delivery network. Now what is this content delivery network? There are some cases where your front end is just simply static, like nothing really changes in that, and there are some photos, there are some videos that can actually be accessed via CDN. Now what is CDN? So CDN is pretty simple. Whenever you make a request, if that is static and all, that doesn't changes, so the request directly goes to the CDN. The request doesn't goes to load balancer or the servers. Why? Because CDNs are faster. That's the simple reason behind it. So by the way, when it comes to the CDN, so what happens? This is the client here, of course. So if you have the static data, so if you are making a request and that request is for the static data only, so you will have something called CDN over here. And again, Amazon provides this service as well, and you can, all the providers they do. Okay, so you will have something called CDN over here. Let me do one thing, make it a circle. So this is gonna be sort of CDN here. So you will just simply send the request to the CDN, and CDN will just simply will give you the response back. So this can be 1, this can be 2 directly. So 1, and this can be 2 as well. So what happens that instead of sending the request to the load balancer, the request will directly go to CDN. Again, for sending the request to the CDN, you need to have the IP address and all. So this should ideally be 3 and this should ideally be 4, because first of all the request will go to the DNS. You will get your public IP address. Once you get the public IP address, the request will actually go to the CDN, and this is gonna be the overall flow. That simply means if something is saved in the CDN, because they are faster, so the request will not go to the server. And especially what things need to be saved in the CDN? The things that do not change. So suppose you have your HTML page that doesn't change, that is just simply static page. You have your photos, you have your videos, you have your files. You can just simply save them in the CDN, and whenever you want to access them, you can just directly make a request to the CDN and you will be getting the response back. So this is how content delivery network can be used as well. So ultimately what all we have discussed. First of all, we talked about simple client, just a sec, let me correct this. Okay, this is fine. So we talked about simple client server architecture. Then we talked about we introduced the database, how we are gonna be using a database. And once the database was introduced, then we talked about multiple servers, how you can just simply create multiple servers, and load balancer will be used for just simply balancing the node and all. So this thing we have gone through as well. Then we talked about single point of failure. That simply means there could be possibility that your database may go down, and in that case how will you be managing that? So we talked about master slave architecture. That simply means all the writes are going to be happening here, all the reads are going to be happening from the slave side, and if one slave dies, the master will just simply spawn a new slave, other slave will still up. So if one slave dies, you already know, like another slave just simply handling the request. If master dies, one slave will become the master, and after some time master is gonna be coming back, and then it will just simply sync the data from the slaves. It will just simply have the data. So this is how it goes on. So we talked about DB scaling as well, and apart from this particular thing, then we talked about caching. Like if you don't have caching, the request will go to the database again and again, and because of that particular thing, you are gonna be having caching. So instead of sending the request to the database, the request will actually go to the cache. Cache contains the information that you need. You will directly get the response back. The request will to the database will not go, and if this cache doesn't have any data, then of course the request will go to the database and all. So this thing we have talked about this talked about it as well. So ultimately what happens that it happens like this. So it will check the data in the cache. If the cache does not have any data, so suppose if it doesn't have any data, then it will just simply send the request to the server, and this is how things are gonna be going on. Okay, by the way, let's not have it here, but this is how the overall flow is. Okay, then we talk about CDN, content and delivery network, and the thing is that content delivery networks, they are present everywhere. So they are present in India, and especially in many places of India they are present, like that. They contain the files that do not change, right? So in that case you do not need to run a lot of business logic behind the scene. You have to just simply get the request, you have to send the data, right? This is the only thing happens, and that is why sort of they're cheaper, if I'm not wrong. Okay, because they do not have to handle, job is done. So we talked about this thing as well, and this is sort of called proxy cache as well. So cache, so this particular thing is done as well. I mean, pretty simple. Like, this is most of the things are just simply theoretical. User 1 shared DB, just a minute. That's sort of right. I mean, it does make sense. The thing is that what is the problem right now, and hopefully it's gonna be over soon, because there are a lot of things. Probably this is the last thing we are gonna be discussing, and then we'll take a break and then we'll continue. The thing is that if this is the client that simply makes a request, suppose this client signs up, the request goes through the load balancer, and suppose this is the server that got used. Okay, so this is the server that got used, and as the user is logging in, suppose, so as the user is logging in, the session information will be saved in this particular server, right? And as the session information is saved in this one, whenever this client sends the request, and if the request goes to this one, this does not have the session information of the client, and hence the client will not be able to validate something. So it's good to have many servers, but how will you make sure that whenever you are logging in, all the servers, they have the access of your session? Because suppose server 1 has your session information. If you send the request to the server 1, server 1 will be able to identify you, authenticate you. But if the request, actually load balancer sends the request to the server 2 or the server 3, so server 3 does not have any information about your session and all, and because of that thing, what will happen, that you will not be authenticated. So even if you have logged in, if the request goes to the other server, so at that time the problem is that another server will not be able to authenticate you, hence it will just simply unauthorize you. So in that case, what you can do, so there is something called a shared DB. So let me keep this caching thing over here, that would be better. Just like this. And there's another thing called let me create this shared DB. So we have this DB over here. Ultimately we have multiple replicas, we have multiple slaves over here. That's okay, that is mainly for the saving the data and all. Now we need to have the shared DB as well, and this shared DB will mainly be used for persisting the session. Why? Because if you are logging in and session is getting stored inside the server only, then that's gonna be problematic, because if the session, you have stored the session here inside the server 1, there is no session in the server 2, there is no session in the server 3. So what will you do? Whenever the user signs up, at that time you are gonna be just simply making a request to this shared DB, and this shared DB will just simply store your session for you. So ultimately you will have session over here. Okay, so you will have the session stored in this particular shared DB, and whenever you the client is gonna be sending the request again, so because the client will definitely have the session ID, so you using the session ID, you will make a request to the shared DB. It will give you the session if that exists, and if it will just simply give you the response. If the session does not exist, then of course that's gonna be problematic, and it will say the session does not exist, you are an unauthenticated user. But if the session exists, so whether the request goes to the session 1 or the session 2 or the session 3, server 1, server 2 or server 3, it doesn't really matter. Those servers will just simply make a request to the shared DB. Shared DB will give the session if that is available, and then in this way the client is actually going to be authenticated. So especially when you are auto scaling the servers, at that time this problem occurs. Like if you are actually storing the session inside a particular server, then there are many servers, hence the authentication problem will occur. And that is why we just simply save the session in a separate database, so that we can just simply make a request to that particular database, and we'll be able to check whether the user is authenticated or not. So this is how it just simply goes on. Okay, and then multiple data centers, let's even talk about this particular thing. So when it comes to multiple data centers, okay, let's talk about this particular thing later. As for right now, this much is enough. Now now we have to actually go to the global level in the sense. So far we've talking about the things what countryside level, because you will send the request will go to the load balancer will just simply load balance the request and all, and ultimately database is going to be used, shared DB is going to be used, cache is going to be used, and on top of that, if that is the static stuff, CDN is going to be used over there. But if that is a global request, so whenever you make a request, so the load balancer will have to make sure that where should the request actually go. It should go to India, USA, I mean any country, it doesn't Japan for that sake. So ultimately whenever you are making a request, so load balancer will have to make sure that okay, which country is this request should go to. I mean which country is this request should what can I say, yeah, which country does this should this request belong to, and on the basis of that particular thing, the request will be sent to that particular country. And not only that, in that particular current country there are gonna be many servers, and hence we will have to make sure that there is something called geo load balancer, global load balancer, that just simply manages this particular things. And there are gonna be many data centers. So here we talked about only server stuff here. There are many servers and all, but ultimately those servers are gonna be inside data centers as well, right? So on the global level wise, globally what will happen, there can be many data centers as well, and those data centers will have these servers and all. So we will have to take care of this one as well. So data center, suppose one, this is the data center 1, this is the gonna be data center 2. So this way there can be multiple data centers. Now how will you be, first of all, sending the request to those data centers, and after once the request is actually received to those data centers, now those inside those data centers you have multiple servers and all. So it's not like it ends over here. Inside those data centers you have multiple servers, and not only one, you have one, suppose environment, then you will have something like combination of many group of servers. And suppose this is the Kubernetes cluster that you have created inside that particular data center, and that Kubernetes cluster contains many servers inside it. So this, so this way it will just simply keep going on. So we have to talk about this thing here as well, exactly how things are actually handled in this particular case. This is the normal case in the sense normally this should happen, but now when it comes to globally, so you have to handle more things as well. So we are going to be talking about that very soon. Until then, I'm just simply going to be taking a break, of course. How long has it been? Whenever I'm going to be live, I'm going to be talking about this thing only, because this needs to be done anyway. So let's just simply talk about it very soon. Until then, take care. I'm going to be catching up soon. Bye bye.